Good morning. In our previous class, we have discussed the sequential circuit, and there are two types of sequential circuit at that time. One is the asynchronous, another is the synchronous sequential circuit. We have already discussed. In asynchronous circuit, there is no clock signal, but in case of synchronous circuit, there is a clock signal. Okay. So after that, both are memory devices. So in sequential circuit, I have already mentioned that there is a feedback from output to input. That is, the output does not depend only upon the present input, but also depend upon the previous output. So in sequential circuit, there are basically two types for memory device. One is the latch, another is the flip-flop. Both are storage device. Both are bistable memory device. That is, the store either 0 or 1. Similarly, this is also bistable memory device, store 0 and 1. So what is the basic difference between latch and uh, flip-flop? Second difference, there is no clock signal, but here is neat clock signal. For control, and as it is no clock signal, it is equivalent to asynchronous and this is the synchronous already mentioned, and the another is the gated level or level trigger. This is the level trigger, and this is the S trigger. S trigger. So these are basic difference between the latch and flip-flop. There are different types of latches and different types of flip-flop. First, we discuss the latches. Okay. So first, latch. So what is latch? A latch is a electronics device, sequential circuit, which can store 0 or 1 without clock signal. And first is the SR latch. SR latch can be designed with help of two types of gate. One is the NOR gate and other is the NAND gate. Okay. So this type of latch can be explained with help of NOR gate and NAND gate. First, we discuss with SR latch with NOR gate, and then I will discuss the SR latch with NAND gate. First, the SR latch with NOR gate. That is, we construct the latch with NOR gate. For the symbol, so there are two NOR gate. This is one and this is, so, and one is the S and other is the R. So this is S input and this is R the input, and this is the output and this is another output, and this output is Q bar and this output is Q, and there is a feedback. So from this output move here and another from this output join here. So one input is the S and other input is the feedback from Q output, and here one is the R and other is the Q bar and from Q bar. So this is the basic design for the SR latch. Now we will discuss the for the truth table. First, you have to understand what is the function of NOR gate. For NOR gate, if there are two input 0 0 0 1 1 0 1 1, suppose, and this is the output. What is the basic logic? Basic logic, if any one is 1, then output is 0. So this is 0, this is 0, this is also 0, and this is 1. This is the basic logic of NOR gate. That is the opposite of OR gate. In OR gate, anyone is 1, then output is 1, but not anyone is 1, then output is 0. So this is 0, this is 0, and this is also 0. This logic we will apply in the truth table of SR latch. First, we write S and R. One is the Q and that is the Q bar. That is opposite of Q. So